All right, so this is our last chapter for 1035 Business Math with Calculus. So we're going to talk about Chapter 5. We're going to get into finance. And so everything that we've done up to this point kind of leads us into this finance category. And so for Section 5.1, we're going to talk about simple and compound interest. And so we're going to talk about the definition of what it is, and then we're going to talk about the properties of it and how it works, and then we'll do some application problems that go along with it. So the first thing we want to talk about is simple interest, and simple interest is the interest drawn solely on the original value. So we put in $5,000 into our account, and the interest is only calculated on that $5,000. Okay. So for this is the formula that's in the textbook, and so it says interest is equal to PV. Well, PV is the present value, so that's how much we put in or the loan that we take out. R, lowercase r, is the rate of interest, and it's per year. So, it's at 5% or it's at 7% or so on. So that's a little r. And then our T is time, and that is usually in years. Doesn't always have to be, but for the most of the questions that we'll do, we'll have it in years. Okay. And so then that leads us into being able to find the future value. All right, so the future value is the value of the loan account or account after it's reached maturity, and maturity is just the time that's been met. So if you take out a loan and you're expected to pay it back in 10 years, then the maturity time would be 10 years. Okay, if you put in a savings account and you want to leave it for 5 years, after 5 years, that's when that's your maturity time. Okay, and so if we look at this from an algebraic standpoint, we have PV times 1, so that's the present value, plus PV RT. Okay, so in this formula, what's happening is we're going to calculate the interest by PVRT, which we discussed on the previous slide, plus the original present value. Okay, so if I put 5,000 in, and then that account's worth 5,600, then that's 5,000 plus the 600 of interest. Okay, just as an example. So let's say that we have this savings account. So Callie has placed 5,000 into a savings account that has a return of 5% per year. Okay, so just to make sure that we keep track of everything, we need PV, we're going to need lowercase r, and then we're going to need T. Okay, so PV is present value, so we put 5,000 into the account. All right, R, so it has a 5% per year. Okay, so 5%. However, we need it as a decimal, so I just move the decimal twice, divided by 100, so it's 0.05. And my time is 3 years. Okay. All right, so to find the future value, that's the value of the account. What is the value of the savings account in 3 years? So I say that's 5,000 times 1 plus my rate is 5%. And my time is 3. Okay, I plug that in the calculator and I get 5,750. Okay, that answers the value of the savings account. Now, if I wanted to know the interest part, I could, according to that first slide, take my present value, multiply it by my rate and my time, or if I know that I put 5,000 in originally, then I could just subtract 5,000 off and say, well, that's $750. That's how much interest was accrued over the time of the account. All right, so the interest was $750, and that made the value of the account $5,750. So let's do the same kind of thing to this loan. So John took out a car loan for $10,000. So my present value for this situation is $10,000. My interest is 6%, so 0.06, and my time is 5 years. Okay. So how much interest will be paid on the truck? So I need to find the future value. Okay, so I can find the future value and subtract it off if I want to, or I can use that original interest and say, well, that's the PV times RT. Yeah, that's your call, whichever way you want to do it. I normally find the future value and then subtract off the original amount, because then I can answer two questions with one formula, but you don't have to do that. So here I have 10,000 times 0.06 times my time of 5. Okay, and so I plug that in the calculator and I get 3,000. So this situation with the $10,000 loan at 6% interest for 5 years had an interest of $3,000. So now I want to talk about compounding interest, and compounding interest happens when the interest is applied to the present value and the interest accumulated. So think about it along the lines of a credit card. Okay, each month your credit card company calculates a payment that's based, with the balance. All right, so they calculate that balance by adding interest to the previous balance and then calculating the interest for that new balance. Okay, so that's what's going to happen here. And instead of multiplying, now we have an exponent. So everything stays the same, except we introduce this term n, and that is the number of compounding periods per year. Okay, so let's do an example of this. So let's suppose that we have $8,000 invested into an account and it accrues interest at 8.65% compounded annually. So what is the value of the account after 7 years? So I have PV, I'm going to have R, I'm going to have T, but now I also need to account for N. So my PV is 8,000. My R is 8.65% or 0.865. My T is 7, and I'm compounding annually. Okay, so that's very important. So since I'm compounding annually, my N is 1. Okay, if I were compounding weekly, my N would be 52. If I were compounding daily, 365. Compounding monthly, 12. Okay, so pay attention to your compounding periods. All right, so I have my future value is my present value times 1 plus my rate of 0.865 over N, which is 1, raised to the T, which is 7, times my N, which is 1. Okay, so I didn't have to write 1 down. I just did, just for the sake of showing it, but you don't have to because it's 1. Okay, so I plug this in the calculator, and I get $14,298.75. So that's the value of that account after 7 years. Okay. All right, so that wraps up our compounding interest. However, there are times when maybe you have a goal in mind that you want to reach, and you have an amount that you can put in today, and that's the only amount you can put in. And you know how long you're willing to let it last, but you need to then find the rate, okay, the proper account with the rate that you're looking for. So here I have a present value of 9,000. I have a future value that I want to include this time of 11,446. I have a time of 6. I have a rate of 6%, or the rate is what I'm wanting to find. And then I have an N value, which I'm compounding annually again, so my N is 1. Okay, so what I have is 11,446 is equal to 9,000 times 1 plus R, I don't know, divided by N, which is 1, so that's really just R, raised to the 6th. Okay, so now I can solve this. So I'm going to divide by 9,000, divide by 9,000, So I have 11,446 over 9,000. I would not advise you to evaluate this. I would leave 11,446 over 9,000 because of rounding error can happen, and when you round 2 or 3 times in a single function or solution, you could be off enough that your Pearson homework or test will count it wrong. So I would not. I would just leave it. Okay. And so now I have a power of 6, so I can raise this to the 6th root, or a fractional exponent of 1 over 6. Okay. And that leaves me with 11,446 over 9,000 raised to the 1 over 6 is equal to 1 plus r. So then r is equal to, when I subtract the 1 over, I get all this. Okay. So I have that. Plug that in the calculator, and I get 0.0488. Okay. When I convert that to a percent, I get 4.9%. Okay. All right, so that would be that for solving for the interest. So that would be the rate that I would need to get back to 11,446 after 6 years. All right, so the last thing that I want to talk about is APR and APY. So APR is the annual percentage rate, and we often call that the nominal rate. That means that's the rate in theory or in name. So, for instance, you go to buy a car and they tell you, well, it's 7% APR. Okay, so that's the rate that they give you. However, the annual percentage yield, APY, is the actual amount of interest applied. And that happens when we have compounding interest more than once a year. Okay, so for APY, when the nominal interest rate is 6%, compounded quarterly, means 4 times a year, so my n's going to equal 4. Right. I'm going to choose a present value of 1 just to make life easier. But I have a rate of 6%, or 0.06. And then I have a time. Since I only need to know what's happening annually, I'm just going to let my time equal 1. And I already know that my n is equal to 4. Yeah, so essentially what I'm going to find here is my future value. Okay. And I'm going to let PV be 1 times 1 plus R, which is 0.06, over N, which is 4, raised to the N times T, which is 1. Okay. So I'll plug that in the calculator, and I get 1.061. Okay, that is my future value. All right, similar to the one earlier where we just wanted to find the interest that was drawn on it, I can just subtract off the original value. So I'm going to subtract 1 here. That leaves me with 0.061, or 6.1%. So this is my APY. Notice that the APY is higher than the APR. That's because they are calculating the interest more than once a year. If they only count it once a year, then the APR and APY will be the same. Okay? All right. So that is this section. Here are some practice problems. So I want you to do these on your own, and I'm going to give you the answers. So the simple interest for number 1 is $80. The value for the account after 13 years here is $26,126. Okay, and then the APY for semi-annually is 5.06%. Okay, so those are the answers for those three, and I want you to practice those on your own before you start the homework to make sure that you have a good grasp. If you need help with these or any of this section, please feel free to email me, and have a great rest of your day.